Hello, in this video I'll be doing the demo of the experiment 3, which is to create a containerized experiment. The main need is to improvise and make efficient use of the nodes allocated. So if for this experiment we start off with an example of star topology. Here we have 10 nodes in total. The one is called the center node and the other 9 nodes are called the satellites, and each is connected to the center node with an 100 Mbps link and a 10 millisecond delay. The NS file, let's go ahead and see how this is done. So this experiment also is done in a similar way by choosing begin an experiment and by giving the name as lab 4 and description as containerized experiment. And NS file is chosen to set up 2 nodes with which are running on Ubuntu and which is linked using a link cable, and swap pass is changed to 1 and swap in immediately is clicked and submit is clicked. I'll go ahead and show you how this is how it swaps in, and as I've already done this. So this is the one that is created. This will be the NS file that it produces. It runs on Ubuntu 14.04 and the container 0 is created. This basically is a start command which runs a particular file or an application as soon as the nodes boot up. And here you can see the details tab with the qualified names in order to SSH to the nodes. So the next step is to, once the nodes are created, in order to see a workaround to check if the nodes are up and running, is to ping the nodes. So here I've pinged the nodes and I've got the response with the TTL and the RTT. And similarly I've pinged the N1 node and center node here, and we can see that the nodes are up and running. Next is to see the startup commands which we have specified here. The startup commands create a file with this name n0 lab3 virtual w542.isi.deterlab.net. It would basically, the content of the file would basically be the time and the date of the current day of the time when the node actually booted up. So we can also go into the folder user directory and check for these folders in order to make sure that all nodes are up. One way to basically do the experiment is used to take other containers as well. So here we have a table which defines the container and the parameter on the container that it uses. So in this example we take keymu and we try by giving the parameter command as default container, and we try to SSH the experiment is created successfully, and in order to know that the nodes are up, we try to SSH to the nodes and access information from that. The next thing is to mixing the containers. Here we can set the container type for each satellite node as well. So this is done by using the command tb@node attribute and give the node type as keymu as shown in this table. So this will basically create the satellite nodes running on keymu. You can as well SSH to the nodes like this in order to know that they're up and they're functioning properly. In order to get this up a notch, we try to add a physical node as well to the container. So here we add an N8 satellite which as a physical node, and then so basically we'll have a container as well as a physical node named N8. So you can see I've already done that, and we SSH to the the container center node as well as the physical node, and we know that both of them are up and running. The next step is to set the OpenVZ parameters. The one advantage of using OpenVZ nodes is that you can set the CPU bit or the disk size of the disk or the OS flavor using OpenVZ template. So here in our example we set the center to be running on Ubuntu 12.04 and each satellite node to be running on disk space of 20 giga. So you can see that we have set it up, and the nodes are displayed with the container here. We can also see the visualization for this. We see that there is one node and there is a one container and there is a physical node. The next is to set the key move parameters. This is basically used to mount the given users onto the directory, and this is done by using the command as key move prefer users and the usernames that we provide. So this will create this basically tells the container to mount the users which are provided in the command. The next step is to basically rearrange the topology or by changing the packing factor. This is done by giving the command packing to. I mean, in this example we have packed with every node having two system physical nodes. So we see that in the visualization we see that each node is packed with the factor of 2. It's the same number of nodes, but it is spread across in this example. We next get into a multiple passes, which is basically a more sophisticated way of packing. So this is basically done by using something called as pass pack. This is a table of pass against a packing factor. Usually pass 0 is assigned to the center node. This is assigned to LAN 1, LAN 2 and LAN 3. This is assigned to 1, and LAN 1 has 20 nodes, 20 physical nodes, and LAN 2 10 and LAN 3 5 respectively. And in order to access the image, we give the path, and we can SCP to our system later, and this basically it's done. So we get the following image where there is center node and there is 3 LAN with 20, 10 and 5 as given in the command. The next step is when there is a way to fit more nodes, physical nodes, so we tend to give pass back here, and the resulting image here would be the following, which again is got by giving the command, running the command to get the image. Next is to use nodes only. If there are constraints on the packing factor and it's not flexible, we can use nodes only. This will basically produce a more symmetric distribution of nodes. So this is also obtained using this. You can see it's more symmetric here. Next step here is to give use the command known as pass size. Here it gives the user an more hold on how many machines they would need to contain their experiment. So here we give pass size and the following parameters, and gives more flexibility to the users, and the resulting image would be this, which is again got by the similar command running. Next step is to set default invocation. This is basically packing 5, and the pass pack here is 0 to 1. Will pack pass 0 with a factor of 1 and 1 with a factor of 20, and for the rest 2 it takes the default of factor 5, and the resulting would be this, and the resulting image would be this to show the default invocation that is happening. Similarly, it is done using this. Uh, we'll either allocate this to container 0, this, and either this or this to container 0, and this to the container 1. And the last combination is to mix and match both pass size and pass pack, and as those two commands can be used together, and the resulting image would be this again image is again got using the same command to access the image and SCP to our local system. So this is the resulting image that we get. So this is the end of laboratory experiment 3. In this experiment, we learned how to create a containerized experiment and to play around with it by using packing factor and pass, and also to add a physical node to it and access and ping those nodes, same as the physical node. So this is it. Thank you.